In this tutorial, we are going to discuss this question which is appearing on the screen. Find the coordinates of the point on the curve. This is an equation at which the tangents are parallel to the y-axis. First, we needed to know what is the tangents parallel to the y-axis, relevant with the differentiation always. If it is written there parallel to the tangents are parallel to the y-axis, always we needed to use dy by dx equals to 0. This is our main thing. If the equation is written tangents are parallel to the y-axis, it means that we needed to write dy by dx equals to 0. So we know how to differentiate this. It's an implicit function. Let me write the equation: x square plus 2ax plus y square equals to 0. So if we differentiate with respect to x, it gives us 2x plus then 2a, and that one is 2y dy by dx. That is our expression. Dy by dx equals to 0. So here, while we are differentiating y square in terms of x with respect to x, it gives us always d by dy of y square into this is dy by dx. We first needed to write this one, then from here we got 2y dy by dx. This is actually that expression. Now make dy by dx as a subject, so we can write 2y dy by dx. If we take that two terms on the right side, which is minus 2x minus 2a, so now we can make dy by dx as a subject. It gives us minus 2, we can take common, then it is x plus a divided by 2y. Yeah, we can cut out this 2, then finally expression is remaining minus x plus a divided by y. Now we need to consider, because it is parallel to the y-axis, which is dy by dx is 0, so let you consider dy by dx equals to 0. It means that that expression minus x plus a divided by y equals to 0. From here you can write by cross multiplication minus x plus a equals to 0, then x plus a equals to 0, so we got from it x equals to minus a. So this is our value of x, but the question is asking coordinates. X value is minus a, we need to find out the y value. We can use the main equation to get our value of y. So let us use the main equation, which is x square plus 2ax plus y square equals to 0. We are going to put the value of x here. It gives us minus a whole square plus 2a into minus a plus y square equals to 0. Then from here, positive a square minus 2a square plus y square equals to 0. So we can write it y square equals to positive a square, because we got from here minus a square, then y equals to plus minus a. So for a value of x which is negative, so we can write as a coordinate minus a comma positive a, and another coordinate minus a comma minus a. So this is our answer of this question. Another question, which is find the coordinates of the points on the curve, this expression, at which the tangents are parallel to this line, and another written perpendicular to this line. So if written here parallel to this line, just we need to find out the gradient of that line first, then we can consider dy by dx equals to that gradient. So gradient for part A we got from here x plus y equals to 1. It means that we can make y as a subject, minus x plus 1. That equation is a straight line equation, we know that, which is mx plus c, and this m is the gradient. Accordingly we can write here the gradient as a minus 1. So this is the gradient, though it is parallel, so this minus 1 actually equal to the dy by dx of the curve. That is our main equation target to find out dy by dx equals to 0. So let me differentiate the expression. This expression, if we differentiate with respect to x, it's an implicit function. So it gives us 2x minus 2y dy by dx. Then on the right side we have to apply the product rule, which is 3x dy by dx, then plus y into 3, because we applied here the product rule in 3xy, then minus 39, if we differentiate we got from there 0. So that is our total expression. Now here written dy by dx equals to minus 1, replace dy by dx by minus 1, then the expression is 2x minus 2y into minus 1 equals to 3x into minus 1 plus 3y, because we replaced dy by dx as a equals to minus 1, dy by dx equals to minus 1, we replaced from here. This is our condition. So now simplify it more. 2x plus 2y equals to minus 3x plus 3y. That is our expression. So which gives us 5x equals to y. So this is one of the equation which gives us 5x equals to y. Now the question is asking us to coordinate. So this equation and that equation we needed to solve now. So therefore from the main equation you can write it. If we replace y as a 5x, then you can write easily x square minus 5x whole square equals to 3x into 5x minus 39. That is our expression. So it gives us minus 24x square from the left side, and from the right side it is 15x square minus 39. So it is minus 14 minus 15, which gives us minus 39x square on the left side, and right side it is minus 39. So we can cut out minus and that two value, 39, so you can write it x square equals to 1. So from here we got the value of x equals to plus minus 1. So this is our value for this equation, x value. Now we needed to find out the y value by putting this value in the main equation again. Sorry, you can use this equation for the y. So when x equals to positive 1, then y equals to 5 into 1, which is 5. Then we can write here when x equals to negative 1, then y equals to 5 into minus 1, then it gives us minus 5. So our set of values of x and y as a coordinate, you can write it 1, positive 1, positive 5, then another one, negative 1, negative 5. So this is the answer of the first question. I mean part is B, perpendicular to the line of that expression. What is that? So actually the equation having with the same gradient of that expression, m equals to minus 1, though it is perpendicular, so you can write here dy by dx into this gradient of minus 1 from here, and this product gives us minus 1 again, though it is a perpendicular. So from here you can find out the dy by dx. Right now we got 1. Just we needed to replace our dy by dx in the expression, that expression we already differentiated for the part A. Now we need to put dy by dx equals to 1 in that expression, in this expression. Let me put dy by dx as a 1. So then it is twice x minus 2y into 1, then 3x into 1 plus 3y. So finally we are getting 2x minus 2y equals to 3x plus 3y. So it is actually minus x equals to 5y. So from here you can write x equals to minus 5y. So this is another equation. By solving this equation and the first equation, we are going to find out the coordinate now. So put x in the first equation, I mean we need to substitute, which is x as a 5y. So replace this x as a 5y, say we can write it minus 5y whole square, then minus y square equals to 3 into minus 5y, then y minus 39. So from here you can write 25y square, then minus y square equals to minus 15y square minus 39. So 24 24y square plus 15y square equals to minus 39. From there we can write 39y square equals to minus 39. Y square equals to minus 1, but it's a quadratic equation, so it is impossible to find out the value of y. So there is no point, we can conclude here, no point exists when this curve tangent perpendicular to the line. So we can conclude here it's not exist for perpendicular. That is our answer. So next question is find the gradient of the tangent at the point where the curve crosses the line y equals to 1. So first we needed to find out the x value, if is there any x. So let me substitute this y in their equation. So then you can write it 3x square plus 4x into 1 equals to 7 into 1 square plus 8. We can write it. Our coordinate in that case minus 3, let me write the coordinate first, 1, and another one when x equals to 5 by 3, y the same value 1. Now we are going to find out the gradient. We know that the gradient is always dy by dx, dy by dx we needed to find out. So here the expression is again one implicit function. We are going to apply here the differentiation. So if we apply differentiation here, it gives us 6x, then 4xy. Actually we needed to apply here the product rule, which is 4x dy by dx, then plus y into dy by dx of 4x gives us 4, and on the right side it is 14y, then dy by dx plus 0. Dy by dx, if we take common, it gives us 4x minus 14y equals to minus 4y minus 6x. So dy by dx, make dy by dx as a subject, and it gives us minus, you can take common, 4y plus 4x, 4y plus 6x divided by 4x minus 14y. We can simplify more for this equation. If we take two common from the upper and lower side, and we can cut out, and minus sign you also can cancel, it gives us 2y plus 3x, and on the bottom it is 7y minus 2x. I took minus 2 common from the below, and from the top is minus 2 as well, then cut out, then automatic you will get this equation. Now it's very easy. At the point at, we can write here at minus 3 1 gradient, because this is our question. Gradient means we needed to put our value here in this equation, which is 2 into 1 plus 3 into minus 3 divided by 7 into 1 minus 2 into minus 3. So it gives us 2 minus 9 on the top and 7 plus 6 on the bottom, which is minus 7 divided by 13. So minus 7 over 13. This is the first answer at the point minus C1. And when the point is 5 over 3, 1, then gradient equals to, you can write, let you put the value 2 into 1 plus 3 into 5 over 3, then on the bottom 7 into 1 minus 2 into 5 over 3. So let me simplify a little bit, then it gives us 3, 3 can cut out. 5 plus 2 is 7 on the top, but bottom it is 7 minus 10 over 3. So it is 7 by, on the bottom it is 3 7 is the 21 minus 10 over 3. It gives us 7 into 3 by 21 minus 10, which is 11. So finally we got from here 21 divided by 11, and that is our answer of the gradient of that expression. Hope you understood the questions we have done so far for the implicit function, and you're welcome to see my next tutorial as well. Thanks for watching.